The question is, okay, we should trust in data, but how do you trust the algorithm so that we can trust the data? Okay. And if it is purely based on the results of an algorithm, do you also rely on any other means to trust the algorithm? If so, how?
Yeah, I think so. As a as a true researcher, I'm sure Jin can comment on this also, is you got to always look at things as a suspect. It's like a detective. So you look at data, you look at algorithm, but ultimately it's you who's making a call, right? And the responsibility, again, the whole juicer operatorship analogy kind of translates here. This responsibility is on you, because ultimately people should trust you. When I've had data scientists who say, here is the 3 different models and here is their accuracies, Abhi. I've run all 4 models that are available. And my question is, I've not hired you to just run this data to 4 models. I'm asking you, what is your recommendation? What forecast are you going to sign your name on? And that's a very different thing. And when somebody needs to do that, then you need to actually look at the data as a suspect. You need to do a model as a suspect. And you need to really spend time thinking about what is your confidence level on the result that the model is producing, right? And what is how do you do some uncertainty quantification? Because there is not, no prediction is 100% accurate, but is it repeatable? Is it explainable, right? And does it make sense, right? So it's really the correlation versus causation. If it's applicable, and it's not always applicable, right? If you're doing mechanical failure prediction, you must know that, hey, just because the steering wheel is breaking and the brake fluid is, brake is failing, oh, they happen all the time. Yeah, but there are 2 separate quality problems that might be happening on a vehicle. Doesn't mean that they're causal. So I think the answer is basically trusted data is really all about making sure you understand the lineage, the source, you understand the field, what is the definition of the field, how is it calculated, so understanding the business context around data. So as soon as you get data for a new area, sales or inventory or wherever you're working on, just make sure you work with the business unit, business SME, subject matter experts to understand what does each of these mean, how are they collected, how are they calculated, which ones are captured fields, which ones are manually calculated fields, so that you can do that feature engineering, right? And then when you are building the model, then it's all about, if you have, statistical models, you can do probabilistic modeling. Or if you're doing machine learning, deep learning, it's hard to explain because the model just gives you result. Then you really need to bank on your test and training data set. And then make sure that your input data is normalized, right? The example I showed you around safety stock, you can give it a skewed input because your demand is always kind of skewed. Instead of running that 500 simulations, like, to give it a normalized input, and you will get a skewed safety stock. So how do you really understand, is your data represents the actual population that you're feeding in, or does your data have bias? You got to understand that if your data has bias, then your result will have bias. And that's something, as a practitioner, you must understand, and validate, and then being able to put your name around an outcome and say, yep, I've done this, and here is the known and here is the unknown, because I don't know everything.